Our role is to decommission and clean up the publicly owned nuclear facilities in this country and to develop a waste management infrastructure. This includes responsibility for implementing geological disposal for higher activity radioactive waste. There are 34 major sites in the UK where nuclear waste exists, and this legacy will remain hazardous for many generations. Some of our waste dates back to the 1940s. As well as coming from nuclear power stations, radioactive waste also arises from research sites, defence, universities, hospitals and agriculture. Not all waste emits the same levels of radiation. Over 90% of our waste by volume has low levels of radioactivity and already has its own disposal route. The rest is known as higher activity waste and materials, and of this, intermediate level waste makes up over 75% by package volume and accounts for less than 3% of the total amount of radioactivity. High-level waste makes up less than 1% of the packaged volume, but accounts for over 40% of the total levels of radioactivity. Other radioactive materials are small in volume, but make up around 60% of the radioactivity. UK policy for these materials has not yet been decided, so they could be recycled or go to a geological disposal facility. High and intermediate level waste is conditioned to increase its stability and safety. These wastes are safely and securely stored in interim facilities. However, this is not a long-term solution for all these wastes and materials. Given the timescale, they will remain hazardous. We should all be concerned about the safe disposal of nuclear waste. It is simply not fair that we leave our children to clear up the waste. We owe it to each other and future generations to face the reality of our current situation. This is a global problem. Most countries with radioactive waste now agree that disposing of it deep underground is the best solution. This is known as geological disposal. Learning from and working with other countries, we continue to develop our understanding of this approach. Our colleagues in Sweden, SKB, have been working with volunteer communities for 20 years. In June 2009, Forsmark was selected as the site for the final repository for Sweden's spent nuclear fuel. The final site selection process was between two volunteer communities. In the UK, after many years of listening to a wide range of views, the government decided that geological disposal is the best way forward. The design of a facility will depend on the rock type at the finally agreed location. The following animation gives an indication of how such a facility could operate. Despite little visual disturbance to the surface, safely below lies a geological disposal facility. Here, deep underground, engineered vaults allow the waste to be kept until it is decided the facility can be sealed. The underground facility will have two main areas, one with tunnels which will contain heat-generating high-level waste, while the second network of vaults will house intermediate-level waste. Intermediate-level waste arrives in two forms, unshielded and shielded. Let us follow an unshielded package's journey through the geological disposal facility. The waste will be transported to the facility in specially designed secure containers by rail, road or sea. This transport container is designed to withstand severe impact and protect workers and the general public from harmful radiation. All transports are regulated to stringent international standards by the Department for Transport to ensure controlled and safe passage. Once inside the facility, the transport containers are transferred by crane onto a drift wagon. which descends on a steep incline deep underground to approximately 650 metres, where it arrives at a specialised reception area. The wagon covers are drawn back, and a heavy-duty crane lifts and moves the transport container to the inlet cell. With the roller shutter closed behind and the outer shield door open, the container is moved into the lid unbolting station. The container is monitored remotely with the aid of robotic manipulators and scanning devices. Upon completion, the container moves to the lid removal station and onwards to the package removal station. Once in position, an anti-contamination shield descends and the package is lifted into the container transfer area above. From here, the waste package travels to a position directly below the emplacement vault. A shielded viewing window makes direct inspection possible at this point. Once remotely secured, the waste package can be moved and stacked in a predetermined position. Utilising the same initial stages of the process as just seen, shielded intermediate level waste finally arrives underground at a dedicated buffer area. A heavy-duty forklift truck picks up the package and transfers it to the emplacement vault. For safety and security reasons, high-level waste and spent nuclear fuel would be handled differently. Arriving in the tunnel, the automated vehicle is positioned remotely over the deposition hole. The machine splits and rotates to a vertical position over the hole. An onboard winch system engages with the disposal canister and lowers it into the hole pre-lined with special clay called bentonite. To cap the deposition hole, the bentonite plugs are winched down into the top rings. Once the deposition vehicle has moved off, both the tunnel and remaining hole are backfilled with a mix of crushed rock and bentonite. This system for waste disposal is a multi-barrier approach, where each barrier performs a specific safety function. These barriers start with the conditioned waste made passively safe, the conditioned waste placed in its container, the container placed in the underground vault, the vault backfilled, and lastly, the hundreds of metres of rock between it and the surface. The ongoing safety of the facility, once it is sealed, would not require any action by future generations. Local communities have been asked by government to take part in a process that may lead to them hosting a geological disposal facility. The government believes an approach based on voluntarism and partnership is the best means of siting such a facility. We know how important it is for the community involved to have confidence and an understanding of geological disposal. We will work closely with communities who volunteer to take part in this process, and such a community will benefit from investment throughout the lifetime of the facility and beyond. We cannot ignore the hazard posed by radioactive waste, or leave this costly burden of dealing with it to future generations. We have all benefited from nuclear activities, whether it is electricity, medical treatments, or security. We have found, with the help of our global community, the best possible current solution to the radioactive waste problem. We all need to work together to make this happen. We want to know what you think, so let us know by emailing us at rwmdfeedback@nda.gov.uk.